Okay, 3.5, we're going to talk about inverse relations and functions. We are going to first find the inverse of a function, and then we're going to talk about graphing a function and its inverse. So the domain of a relation becomes the range of its inverse, and the range of the relation becomes the domain of its inverse. What does that mean? Okay, so if I have in my relation an ordered pair that is -2, 1, in its inverse, those flip. So it'd be 1, -2. An inverse function is just a function that reverses another function. So how do we find that? Here's the steps for finding the inverse algebraically. So where it says f of x, we're going to replace that with y. Then we're going to switch x and y. We're going to solve the equation for y. And then at the very end, we're going to replace y with f -1 of x, because this right here means the inverse of x. Okay, so let's do a couple examples. So first thing I'm going to do is replace f of x with y. Oops. Let me get the right pen. So y equals 2x minus 1. Then I'm going to switch x and y. So I get x equals 2y minus 1. Now I need to solve for y. So I'm going to add 1 to both sides. So I get x plus 1 equals 2y. Then I need to divide by 2. So I get x plus 1 over 2. X plus 1 over 2 equals y. And then my last step is to replace that with, so I write f to the -1 of x, which means the inverse of x equals x plus 1 over 2. And that's my final answer. Okay, let's practice one more. So again, first thing I'm going to do is replace f of x with y. Second step, I'm going to switch x and y. So I get x equals 1/3 y plus 7. Now I need to solve for y. So I'm going to subtract 7. So I get x minus 7 equals 1/3 y. Now, to get rid of that 1/3, actually what I need to do is multiply both sides by 3. That makes the 1/3 and 3, that makes 1. So I just end up with y on this side. And then over here, I get 3 times x minus 7. And I can just leave it like that. I don't have to actually distribute. Okay, so the inverse of x equals 3 times x minus 7. There's your final answer. All right, when we look at the graph of an inverse function, again, we're reversing these, right? So if AB is on the graph of f of x, then BA is on the graph of the inverse of x. Okay, we just flip the x and the y. And then the points AB and BA are symmetric with respect to the line y equals x. So if I look at this graph here, this is the line y equals x, and they are on opposite sides of that line. If you remember in geometry, we talked about reflections. So it's essentially reflected over that line. All right, so let's look at an example of how we would graph this. Okay, so we're going to graph f of x. I'm going to do that by starting with 0, -3, my y-intercept. And then my slope is 2, which is 2 over 1. So I'm going up 2 and over 1. All right, so there's my line. All right, and then the points I graphed would be 0, -3, and then 1, -1. And I graphed a third. You don't have to do that, but then it was 2, 1. So to graph the inverse, I'm just going to flip those. So I'm going to graph -3, 0. I'm going to graph -1. Oops, +1, not -1. And then I'm going to graph 1, 2. And there is so I'm going to label, this is my inverse, and this is my function. All right, and so there is the function and its inverse. Okay, so that is 3.5 inverse functions.